students, my name is Sumit Mehta. So today we are starting a chapter named as limits and derivatives, and in this lecture we will discuss about limits of trigonometric functions. Okay, so I am starting with the one theorem. This theorem states that student, let f and g be two real valued functions with the same domain such that fx is always less than or equals to gx for all x in the domain. Okay, so for some a, if both limit x tends to a fx and limit x tends to a gx exists, then we can directly say that limit x tends to a, this limit of fx will always be either less than or equals to limit x tends to a gx. Okay, so this is the theorem, students. I can plot this theorem on graph paper like this. Okay, so let's say this is your function y equal fx, and there is another function y equal g of x. Okay, and this is the point where they both are equal. Okay, so this is your x-axis and y, this is origin. So this graph says that if limit x tends to a fx exists and limit x tends to a gx also exists, then we can say that limit x tends to a fx will always be less than or equals to limit x tends to a gx. Okay, now let's discuss one more theorem which is called as sandwich theorem. So students, now we are discussing about a theorem named as sandwich theorem, in which it states that let f, g and h be real functions. Real functions means, student, they are defined on every real value. Okay, such that fx less than equal gx and gx is also less than equal hx for all x in the domain of definition. Okay, so for some real number a, for some real number a, if limit x tends to a fx equals L, this also equal limit x tends to a hx, then we can say that limit x tends to a gx will also be equals to L. Okay, student, this is L. Now I can draw this theorem pictorially, which states that this is your hx, this is gx, and this is your fx. So as you can see at this point, it is forming like a, this is fx, gx and hx. So at this point, gx function is sandwiched between the two functions named as fx and h of x. Okay, so this theorem is known as sandwich theorem. Okay, students. Now let us discuss some type of questions on limits of trigonometric functions. Okay, students. So I am writing a question number 1 here. Limit x tends to 0 sine x by x. Okay, these are the important results, student, or you can say they are like a question. Okay, and the second important result is limit x tends to 0 . Okay, so these are two important results that we will be using further in solving questions based on trigonometric limits. Okay, now I am doing the, so these are results. Now I am doing the question, student. The question is given to us as limit sine 4x upon sine 2x. Okay, now I will write, to make this question as this, now I will write this as sine 4x upon 4x into 4x, here sine 2x. Okay, so this will make, student, as 1. Okay, so this is your 1, and this I can write as 2x over sine 2x, limit x tends to 0. So this is also 1, student, by using this formula. So what I am getting here is 2 into 1 into 1 is 2. So the net answer of limit x tends to 0 sine 4x by x is 2. Now part B of this question is limit x tends to 0 tan of x by x. Okay, so this is also a standard result, student, that you can use now onwards. So now I will tell you how to find the limit for this function. I can write tan x is equals to sin x by cos x, and this is into x. So this function sin x by x coming out to be 1, and that we are left with cos of x, 1 by cos x. So after putting the value of x equal to 0 in these functions, cos 0 is 1, so that we are left with 1 by 1, which is 1. So from now onwards, student, you can use this also a standard result, limit x tends to 0 tan x by x is always equals to 1. Okay, I hope, students, now you can do the questions based on trigonometric functions of limits, okay, very easily. So now I am moving onwards to derivatives. Okay, so stay tuned for next lecture on derivatives. Thank you, students. Happy learning.